Almost 40%. Yes, you have heard correctly. Almost 40%. Quantitative comparison questions cover almost 40% of overall GRE Quant. And this video is all about quantitative comparison questions. To understand this, let's first see the format. So this is a sample question from official guide, and at start we have a question stamp that give us the brief background about the question, and based on that we need to compare these two quantities. One is quantity A and one is quantity B, and we have four answer choices. A means that for each and every condition quantity A is greater. Option B means for each and every condition quantity B is greater. Option C means both quantities are equal in every condition. And option D means this relation cannot be determined from the information provided with, because in one scenario quantity A is greater and in other scenario quantity B is greater. The next thing is why quantity comparison questions are very important. The reason is because in each of the quantitative reasoning section there are around 7 to 8 comparison questions, and sometime maybe 9, and based on this condition overall these make up to around 15 questions of the overall scored GRE quantitative reasoning, and this make up to roughly 40% of overall GRE quantitative reasoning. And we are only considering scored quantitative reasoning sections, as there are unscored and the experimental section as well. And the next thing is, the actual reason of making this video is to get a generic and perfect strategies to solve the quantitative comparison questions quickly and efficiently. Let's start with very important and the highly preferred technique, that is mirroring technique. So what exactly is a mirroring technique? In mirroring technique we are considering two quantities as two sides of inequality, but the real issue is we don't know what exactly sign in between them. So we are imagining we have two quantities, quantity A and quantity B, both are the sides of inequality, but we don't know what is the actual sign in between, so we use a question mark sign in between. So before getting further, first of all let's quickly have a recap of the basic operation on inequality first. So in respect to this, first of all the thing is, if we add same number on the both side of inequality, there will be no change in the sign. For example, if I have inequality B is greater than A, and if I add x, a variable, on both sides, and this is same variable, there will be no change in the sign. This will remain as the same sign. Now if I subtract same number to the both side of inequality, again the sign will remain same, just like B is greater than A, and if I subtract x from both sides, the overall sign will remain same. And now the next thing is, I can multiply and divide with same positive value without the change in the sign of inequality. Just like in this, 6 is greater than 4. If I multiply with 2 on both sides, that's mean 12 is greater than 8. And if I divide 2 on both sides, that's mean 3 is greater than 2. So there is no change in the sign. Now the next thing is, and the real tricky part is, that we can't multiply or divide with an inequality. The reason is, in the inequality, if I multiply or divide with a negative number, the signs of inequality change. For example, in the first scenario, if I have 6 is greater than 4, if I multiply minus 2 on both sides, this will become, one side become 12 and one side become minus 12 and one side will become minus 8, but the sign will change because in negative number less absolute value is greater than the larger absolute value. So that's why minus 8 is greater than minus 12, and this inequality sign changes in between. And if I divide this by minus 2, again one side will become minus 2 and one side will become minus 3, and now minus 2 is greater than minus 3. So that's why while dealing with the inequality, in the scenario of the quantity comparison, as we are considering two sides of inequality and we don't know what is actually the sign in between. That's why the issue is we can't multiply or divide with a negative number. So you need to remember two things. First thing is that we can't multiply or divide each quantity or quantity comparison with a negative number. And the next thing is, without knowing the actual sign of variable, the actual nature of variable, we can't multiply or divide each quantity with a variable, because there could be a scenario that variable is positive, so there will be no change in the sign, perfect. But if the variable is negative, in that scenario, whatever the sign is, the nature of sign will become inverse. That's why we can't multiply with a variable unless and until we are sure that the sign is positive. Now see an example. This is again an example from the official guide. Just hold this video for a while and think of this and try to solve it your own, and then see the solution further. Okay. Now first of all, I'm imagining both side quantities at the sides of inequality. So at left side I have quantity A, which is 7w minus 4, and on the right side I have quantity B, which is 2w plus 5, and in the middle I have a question mark. That's mean I don't know what is exactly sign in between. Now the first thing is, remember, in all of these strategies you first need to simplify. So I will try to simplify this and get variable on the one side and constant on the other side. How can I do that? If I subtract 2w on both sides, so on the left side I will have 5w minus 4, and on the right side I will have 5. Now let's simplify further, and if I add 4 on both sides, so I will get 5w on left side and 9 on the right side. So as we discussed, to simplify this, we are trying to get variable on one side and the constant on other side. So in this, if we divide by 5 on both sides, so I have w and 9 by 5. So one quantity is w now and one quantity is 9 by 5. Now let's see the question stem, because in question this thing can't be simplified any further. In the question here provided that w is greater than 1. Now we can compare this very easily. If I consider two scenarios based on this condition that w is greater than 1, so first scenario is if w is 1.5 and second scenario is w is 2. If I consider w as 1.5, then 1.5 is less than 9 over 5, because 9 over 5 is equal to 1.8. And if I consider w as 2, in that scenario w is greater than 9.5. So there are two scenarios. In first scenario, quantity B is greater. In second scenario, quantity A is greater. And that's why we have quantity A possible in one scenario, quantity B possible in other scenario. That's why the answer must be option D, choice D. Right. So just remember, we are considering in this strategy, we are considering two quantities as the two sides of inequality, and we don't know the sign in between. You can perform any operation, subtract, you can add, but you can't multiply or divide with the negative number, and same hold for a variable unless you know the nature of variable, whether variable is positive or negative. And you can do when a variable is positive, but you can't do when variable is negative. And in this situation, just like in this question we discussed, consider two sides of inequality, try to simplify first, and this will help. This is the most common type of strategy which will help you to solve most of the quantity comparison question. Now let's see one more question. In the last question we have some question stem that w is greater than 1, but in this we have just two quantities, x square plus 1 and 2x minus 1. Now let's again think a bit of it and just pause for a second and try to solve it your own. Okay. Now let's solve this. Again I am mentioning these two quantities as two sides of inequality, and I don't know what is the sign in between. So to simplify this, if I subtract 2x from both sides, so on the left side I will get x square plus 1 minus 2x, and on the right side I will get minus 1. Now if you see this closely, on the left side this is becoming a formula which is x minus 1 whole square, and that is equal to x square minus 2x plus 1. So on the left side now I have formula x minus 1 whole square, and on the right side I have minus 1. And this is a basic rule which you should remember, that when you have an even power, the result is always non-negative. That means the result could be 0 or any positive number. So that's why on the left side, the quantity A is always non-positive, either 0, non-negative, either 0 or positive, and the quantity B is always negative. That's why the answer is option A. So this was first strategy for solving the quantity comparison questions, which is a mirroring strategy. Now let's see the other strategy, which is helpful mainly in the solving the questions with algebraic expressions, and that is plug-in numbers. But in this, you need to remember one thing: you need to consider all of the appropriate numbers. Now someone may ask that what are the appropriate numbers which you should consider while using this strategy of plug-in numbers. To understand this, let's see some scenarios on a number line. Okay, I call this a number line approach for any variable. Now this is a number line. We have on the right side of 0 positive axis, all of the numbers are positive, and on the left side all the numbers are negative. And the 0, 1, 2, 3, these are integers, minus 1, minus 2, and in between two integers there are infinite fractions. Now what should be the appropriate number? So these are the main ranges we should consider, and they almost consider all of the nature of the number which could be involved. So but GR is very tricky. Sometimes they exclude the condition that the variable could be 0, 1 or minus 1, because these three numbers will make your comparison relatively easy. So whenever you see such question involving a variable, so first of all try to substitute 0, 1 or minus 1, and if you want to involve all of the relevant numbers in this, to understand this you should consider these four ranges. So what are these four ranges? First of all, first one is when x is between 0 and 1, and the second is when x is greater than 1. The third one is when x is between 0 and minus 1, and the last one is when x is less than minus 1. I consider all of these four ranges separately because of minor difference. Let's see each of these in detail now. First of all, for this the number is between 0 and 1, and if I consider any number, for example if I consider x is equal to 1 by 2, the first thing is if I increase the integer power, the value will decrease. For example, if x is equal to 1 by 2, if I take the square of that, that will become 1 over 4. If I take the cube of that, that will become 1 over 8. And x in this way, 1 over 2 is greater than 1 over 4, and 1 over 4 is greater than 1 over 8. That's why x is greater than x square, and x square is greater than x cube, up to so on. So a value is decreasing. But inverse of this will happen if I increase the root power. For example, if x is equal to 1 by 4, if I take the square root, the value become 1 over 2, and 1 over 2 is greater than 1 over 4. That's why if I increase the root power, the value will increase. So there are two scenarios: increasing the integer power, the value is decreasing, but increasing the root power, the value is increasing. So this is the first range. The next one is if I am considering a value that is greater than 1. For example, if I consider x is equal to 2, if I take the square of that, the value will become 4. If I take the cube of that, the value will become 8. So by increasing the power, integer power, the value is actually increasing. So that's why x is less than x here, that is less than x cube, up to so on. But if I consider the root power, increasing the root power, the value will decrease. For example, if I consider x is equal to 4, and if I take the square root of that, that will become 2. So by increasing the root power, the value is decreasing. Just like in the square root of x is greater than cube root of x is greater than fourth root of x, up to so on. So these are two ranges in the positive axis. Now consider two ranges in the negative axis. For example, if our value is between 0 and -1. But this scenario is a bit tricky in the negative axis, because if we have an even power, the value become positive. But if we have an odd power, the value will remain negative. So we consider those two power changes separately. And if I consider increasing the even power, this will act exactly same as a values between 0 and 1 range. And for example, if I consider x is equal to -1/2, if I take the square of that, that will become 1/4. If I take the fourth power of that, that will become 1/16. So thing is, by increasing the integer power, I am decreasing the value. And just like this, x square is greater than x4, x power 4 is greater than x power 6. But if I consider the odd power, the value is increasing. The reason is, for example, if I have x is equal to -1/2, if I take the cube of that, that will become -1/8. So -1/8 is greater, because in actual, if we consider the magnitude, -1/8 has less magnitude, and in negative, less magnitude value is greater. That's why by increasing the odd power, we are increasing the value. So x is less than x cube, that is less than x power 5, up to so on. But there is another tricky thing, that how we consider roots in the negative axis. First of all, if I consider the odd roots, the value will decrease. For example, if I have x is equal to -1/4, -1/8. For example, if I have x is equal to -1/8, if I take the cube root of that, that will become -1/2. But -1/8 is greater than -1/2. That's why if I increase the odd power, the value will decrease. So x is greater than cube root of x, which is greater than fifth root of x, up to so on. But the real issue is, the real even root of negative value does not exist. Just remember this thing. Only the odd root exists. We can't have a even roots of a negative number. And the last range is, if we have a value less than -1. For example, first considering the even powers. If I have x is equal to -2, so square of that will be 4. 4 power of that will be 16. So there is increase of value. So increasing even power increase the value, just like this. And if I consider the odd power, the value is decreasing. For example, if I have -2, I take the cube of that, that will become -8. So -2 is greater than -8. That's why by increasing the odd power, the value is decreasing. And now if I consider the odd roots, the value will increase. For example, if I have x is equal to -8, if I take the cube root of that, that will become -2. So -2 is greater than -8. That's why increasing the odd power increase the value. And the last thing which we discussed earlier, the negative value don't have a real even roots. So whenever you see a question algebraic involving the algebraic expressions, and you need to use the plug-in approach, so these, unless there is specified that the nature of variable is that x is greater than 1 and less than 1, whatever is specified in the question, if there is no restriction, you need to consider these 4 ranges at least. And almost all of the numbers are appropriate number are considered in this range, because if x is greater than 1, that hold for every value greater than 1, even that is integer or a fraction. And if is that is less than 1, that also hold for that, and in between 0 and -1 and 0 and 1. So there are these 4 ranges which you should consider while using the plug-in approach. So let's see one question to understand this. This is a very interesting question. So we have provided x is a number such that x cube is greater than x. First of all, remember, we are given x is number, not an integer. So number means the value could be fraction, the value could be integer, the value could be any value in number line. But the thing is, we are provided with a restriction that x cube is greater than x. So first of all, you need to see those ranges in which x cube is greater than x. So as we discussed the four ranges earlier, you can quickly see the get one value of each range and see this situation holds true in which of the range. This situation holds true in two ranges, when x is greater than 1 and when x is between 0 and minus 1. And now in those two ranges, you need to compare these two quantities. If we move further, so this is possible in only these two ranges, when x is greater than 1 and when x is between minus 1 and 0. So now let's see both of these ranges and try to compare quantities in these. Let's see the first range when x is greater than 1 and the second range when x is between 0 and minus 1. If I consider two values, in the first range x is greater than 2, in the second range x is equal to minus 1 by 2. And now if I compare, because one quantity is x square quantity A and second quantity B is x cube. So in first scenario, 2 cube is greater than 2 square, and in that scenario quantity B is greater. Now if I see the other scenario, we have x square and x cube. So straightforward quantity A is greater, because even power of negative number always result in a positive number. That's why in this scenario quantity A is greater. So in one scenario B is greater, in another scenario A is greater. That's why the answer to this is choice D. Now let's move to the next approach. So till now we have discussed two approaches, mirroring approach and plug-in number approach. Now this is another approach which is about the approximation. The real concept behind in this approach is that in quantitative comparison questions, we are always asked to compare, not to calculate. So don't waste time in the filthy calculations. Just try to compare these two quantities. You don't need to perform more calculation than needed. You just need to compare those. And you can do even by comparing quantities in parts. We will see one example to understand what is meant by comparing quantities in parts. So let's see this question. Now just pause for a while and try to solve this question at your own. Okay. So first thing is area of circle with radius 4 and second is 48. So let's see the quantity A first. So the formula for area of circle is pi r square, and here radius is equal to 4. So that will and one more thing, the actual values of pi is a bit with extent infinite, 3.14 up to so on, but we will approximate this, for example, to 3.14, and area will be 3.14 into radius square, radius is equal to 4. So this will be 3.14 into 16. Now the approximation thing will come that you don't need to use calculator and try to solve 3.14 into 16. Instead, do this way, that consider 3.14 as a 3 with plus on that. That means the actual value is a bit greater than 3. Now if you multiply these two, you will get 48 plus with a plus sign on that. That means your answer is a bit greater than 48, and you did not need to know the exact answer. And quantity B is 48. So straightforward, by approximation, we will get that quantity A is greater than quantity B. The answer is choice A. So try to approximate instead of solving. Now let's see another question. This is a very interesting question. Again, pause for a while and try to solve this question at your own. Okay. So let's try to approximate. Remember, each and every question of GRE Quant is there are some pattern involved in the question. That's all you need to figure that out. And instead of using the calculator for this question, let's try to think a bit that you need to approximate values, right? So if you see closely, in the quantity A you have 201 over 405, and but instead of 405 if I have 402, so I can have 1 over half value. But in denominator the value is a bit greater, that's mean my value will be a bit less than 1 and a half. And on quantity B side, the first value is 105 over 200, but if I have 210 in denominator, that's mean I have 1 half, but the value is a bit less than 210, that's mean the result is a bit greater than 1 half. So we have compared first part of two quantities. Now let's see the other part, that is 90 by 300 and 51 by 150. So if I have 90 by 270, 270 is thrice of 90, I will have 1 over 3. And but instead in denominator I have 300, that is greater than 270, so our value is less than 1 over third. But on the right side, the second part of quantity B, I have 51 over 153, 51 over 150, and if I take the cube of 53, thrice of 53 in denominator, so that will be 51 over 153, that is 1 over thrice, but I have value less than 1 over less than 153, that's why I have value that is a bit greater than 1 over 3. So based on this approximation, now if I compare these in part, so that we can compare in part now, that this value 201 over 405 is less than 105 over 200, and 90 by 300 is less than 51 over 150. So based on this, I can, after comparing these in part, I can figure out that quantity B is greater than quantity A. So the thing is, you don't need to calculate the exact value, try to approximate value, and just like in this, you may compare these quantities in part instead of solving as a whole. And remember, try to avoid calculator as much as you can. Okay, now let's try to get us some general tips for solving a quantitative comparison question. At first we discuss some strategies. So discuss three strategies: mirroring strategy, plug-in number approach, and approximation. Now let's see some generic tips to solve these. First one is, if we have no variable involved in the question, so never choose option D. Let's see this question. We have the proper constant value on both sides. So that's mean there will be some answer of quantity A and some answer of quantity B. There is no variable involved. That's mean either option A, option B, or option C will be true, but this can't have option D as answer. This will help when we are short of time and we just need to pick one value. So in that scenario, you can just figure out that option D is not possible, and you can choose from any of three options, A, B, or C. The next thing is, one more thing to understand, that now I have variable involved. That's like m over p is greater than n over p. This is a bit tricky question which you will understand in the inequality part, that as someone may just cancel out p and get m is greater than n. Wow, quantity A is greater. But the thing is, I told you one thing earlier, that if we have a multiplier divide both sides with a negative value, the sign will change. So that's mean if p is negative, the sign will inverse and n is greater than m. That's why I want to make you understand one thing, that whenever we are having a variable, only in that scenario we could have a variable, we could have the option D as possible. Okay. The next thing is, always try to simplify first instead of solving. Just like in this, you can solve this quickly using a calculator, but first of all try to simplify. You can perform the prime factorization and you can cancel some values out, and that will help you to solve this quickly instead of using the same value to solve. So thing is, always try to simplify the comparison first. Just like in this scenario, we are given that the question stem is n is greater than 1. So what you can do here, one approach is that you can just substitute some value of n and see what is greater. But the better approach is if you simplify the comparison. By simplifying, this will become very easy, and after simplifying, if you use the mirroring approach, you can solve this question within seconds. But if you start using the approach substituting the values, that will take a lot of your time. So instead of that, always try to simplify first and then see whichever strategy best suits you. The next thing is draw a diagram where required. This is extremely helpful when we are dealing with geometry, because the reason is in geometry, as per the ETS convention, the diagram is never drawn to scale. So you need to consider and draw all of the possible required cases. Just like in this scenario, we are provided that a power station is located on the boundary of a sphere region that measures 10 miles on both sides. So I have a sphere with 10 miles on each side, and 3 substations are located inside the sphere region. So see two possible scenarios. First scenario is if this is a power station and we have 3 substations very much close to this. The second scenario is if I have 3 substations very much far from this. As a quantity A asks that sum of distances from the power station to each substation, I need to compare this with 30. So if I take the distance from this, the sum will be less than 30. But if I take the distance from other extreme, from this side, the sum will be greater than 30. That's why the answer to this is option D. So whenever you see a question involving the geometry, try to consider all of the possible scenarios. And for that, you need to draw the diagram. Okay. The next thing is, very important thing, while dealing with the variable, never assume the nature of variable unless specified. Just like the question we discussed earlier, this question, that x is a number. That doesn't mean that x is a positive number, x is a negative number, x is a non-positive, or x is a non-negative. X could be any number. You need to consider all of the possible cases and see. But in this scenario, there is a bit restriction that possible scenario holds true for this condition, that x cube is greater than x. So the point from this tip is that never assume the variable nature unless verified, unless specified. Just like in this question, if you assume P is positive, quantity A is greater. But if you assume P is negative, quantity B is greater. That's why never assume the nature of variable unless specified. The next tip is that in quantity comparison question involving the variable, you always try to get an answer D first. Because if you think of the question solving for option D, you need to think the various cases. Then if you are not able to do that, then you can go for option A, option B, or option C. But first of all, always try to prove option D is a required answer, and then approach, if that is not possible, then approach for option A, option B, or option C. The main thing which I should explain earlier, the thing is that if any new person to the GRE format should remember these 4 answer choices: option A, option B, option C, and option D. And we discussed this thing that try to avoid unnecessary calculation. This is a comparison, not a calculation. Just try to compare with the least calculation required. The very important thing, focus more on algebra. So because algebra covers a wide portion of quantitative comparison questions, and let's see 2-3 cases. If we have a variable in the question and we are provided with a value, for example a is equal to 2, so for the answer you just need to substitute the value of variable and try to solve. That is a very simple scenario. But if you see the other scenario, we have a variable without any constraint. So in that scenario, our approach should be that we should try to prove that D first. And then if that is not possible, then we go for option A, B or C. And the next one is pretty much common. That is we are given the variable with a predefined ranges. Just like in this, that A is greater than or equal to 1 over 9 or less than or equal to 3 over 4. So we have the predefined ranges for the variable. So in this scenario, it is better test the boundaries instead of using the middle value, the extreme value. Try to test the boundaries first. That will capture most of the cases. And the another scenario is that in which we are provided with a relationship, and for example we are given A is equal to 2b. So if in such questions you just need to see the relationship and compare the variables, you don't need to substitute the values for that variable. Just like in quantity A, I could have A square plus B. In quantity B, I could have B square plus 2A, anything like that. So just try to simplify and compare the variables because we know the relationship between these two variables. Instead of that, don't try to substitute the value of B. For example, B is equal to 2, A is equal to 4. That will a bit waste your time, right? Okay, so this now the brief summary what we have discussed so far. So first of all, we discussed the quantitative comparison strategies, or there are 3 strategies: mirroring strategy, plug-in number approach, and approximation. And then we discussed the generic tips, the general tips. The first one is never choose option D if there is no variable. Simplify the comparison. Draw a diagram where required, mainly in the geometry, and don't assume the variable nature unless specified. And try to prove option D is required answer for the variables case. Remember the answer choices. Avoid unnecessary calculations. It is comparison, not the calculation. And focus more on algebra. So this was all about the quantitative comparison.